Hello everyone, let's solve this LeetCode problem 853. It's called car fleet. In this problem, you are given with three things. You are given a target value, 12, a position of a few cars, and the speed of these cars. So if you take this example 108053 and the speed is this is going to be your input, and for this problem this is what you need to do. So we have this 10 8 0 5 3 are the positions of the cars, and their speeds are 2 4 1 1 and 3, and the target is 12. That means you are supposed to go to distance 12. So this car has to go to distance 12, everyone has to go to distance 12 is here, right? And this is the speed, and from the speeds you can actually calculate the time required to reach the target. So one way to solve this problem is to you sort them and find out how long it's going to take. So in the end, we need to find out which of the cars can actually go in a reach at the same time, and how many groups are there. So uh, essentially, it means if you have a car at the very end, for example, let's reshuffle this. So 10 2 is going to be here. This is the speed, and then 8 4 is going to be here. 8 4 is the next one, and then 5 1 is going to be here. 5 1, and 3 3 is going to be here. 3 3. So you're just shuffling them around, right, based on their distance to the destination. So at this point, we can uh, delete all of that. Um, and if you do that, you can say all these values are needed, and you can also tell the time needed to reach the destination. So for the last one, 10, you see it needs to go 12, and it's currently at 10, and your speed is 2, so it needs to go 2 distance for 2 times, so it needs just one unit of time. And the previous one, it has to go to 12 minus 8, it has to go to 4 distance, and the speed at 4, so it is also going to reach at the time 1 when they all start at the same time. And this third one, this one actually needs to go 12 minus 5 7, and this is speed of 1, so it's going to take 7 unit of time, 7. So this is the times, right? You can see in this pattern that this last one reaches at 1 time 1, and this also reaches at 1, so they actually reach at the same time. And the trick is, if it took, let's say the first one took let's say the last one took 2 seconds, so I'm just making it 2, but this one takes 1, so they cannot actually cross each other. So even though the last one reaches at 2, the first one actually supposed to reach it for 1, it could cross, but they cannot. So the first one is also have to wait and move side by side and reach at the time 2. But uh, forget about that. So you get some kind of intuition what is actually needed. So we need to find the time, and this third one, this one takes 12 minus 3, 9 units of distance with 3 distance per unit of time. So it actually gets 9. So it's a 3 hours. So let's call them hours. So it's a 7 hours, 1 hour, 1 hour, right? And the first one is to go all the way to 12 and a speed of 1, so it takes 12 hours, let's say. So you can see these two has to arrive at the same time, and this one, by the time it reaches it after 7 seconds, you will see both of them actually cross the finish line. So this is one group, and this one again, let's change the color. This one reaches is supposed to reach within 3 minutes, but no, it's gonna get stuck with 3. This one 7, so this 7 reaches here, but it can actually at some point it can actually tag along and go together with the 7 minutes. So you have one group here, the last two, the middle two are the second group, and the third one reaches at 12 minutes, 12 hours, and by the time everyone is crossed, so there's a 3 platoons. So it is very essential that you sort this, but if you sort this, your runtime complexity will be like this. Your time complexity will be order of n, where n is the length of these arrays, and because this is sorting, you also have to use order of n log n on an average runtime. And for space, you still you can actually get by without requiring any extra array, because this time we calculated, you can actually use one of the arrays. So in this case, you might not need any extra space for that, but the runtime is not the best. What you can do is alternative, you can actually uh, introduce this variable target 12 and see how you can actually improve this runtime. So that's approach 2. And for that one, you see all of these values that you calculated, they can actually be placed in this long array. So this can be 0, 1, 2, 3, 4, all the way to 12, right? And now you know you have some values at 10, there's a value. At 8, you have one value, you have something at 5. So let's use another color to mark where our vehicles are. We have something at 10, right? So 10, we have a vehicle. We have something at 8, so at 8 we have a vehicle. We have something at 0, so at 0 we have a vehicle. And we also have one at 5, one at 3. And you can calculate their speeds and place in this array, right? Everything else is basically meaningless, but the one at 10, you can see this one was taking how much? 1 second. So this is going to take 1 second. And then this one before that 8, it also takes 1 second. And then the one at 5, this takes 7 seconds. And the one at 3 takes 3 seconds, or 3 hours, sorry, I mixed up the units. And then the first one at 0, it takes 12 hours, right? Now if you use this, so you don't have to sort really. You can actually go through all of them, so your basically runtime becomes order of n, because you're going through all of them. And after that, you can actually have a reverse iteration, so you can actually go one by one and see if the current time is, so you can actually have a previous time needed. So previous can be something like 0 or something before this. So every time there's a new car arriving after the previous one, you just increment the answer. So this is going to be 1. So, and then the second one is going to be still at the same time, so it is not considered as a new count of a fleet. So you have this same one, and then 7 comes in, it is way higher than the previous arrival time at 1, so this is going to be a count of 2. And then 3 comes in, this is still not higher than the previous one, which is 7, so that case you still have a count of 2. And then finally, when 12 arrives at the destination, so the first one at the 12 hours, you see that this is the third one, so your answer is going to be 3, right? So there are 3 fleets. And with this approach, you have to just go through all of the values once first to create this array. So that is going to be order of n, and then you also have to go through all these values to order of t, where the t is the target. So these are total runtime complexity, so you can actually simplify that as n plus t, and the space complexity would be order of t. So it's a separate solution, but in terms of runtime, it's a little bit better. So let's solve this problem. So to solve this problem, you have to remember that when you divide the position by speed, it might turn out to be something non-integer. And for that reason, we can actually have an array called time, and this can be can take a space of target plus 1, because if something is at the 0th position, which is not probably going to be spelled out here, so we're going to keep extra room for that. And Immediately for integer I equals 0, we are going to loop through all the values within the given arrays, and I plus plus, what you're going to do is we're going to calculate the t, and to calculate the t we have to convert that target minus ith position value and divided by the speed of that value, and we have to place that in ith position, and that is where the t value is going to reside. And now we have to remember that what is the previous arrival time. So we can actually use the previous fleet arrived at time, let's say 0, and for integer j equals time dot length minus 1, and j can be greater than 0 or 1, and j is decrementing, and every time if your previous fleet arrived is actually less than the time it took for this vehicle to arrive, in that case we can actually increment the result, and we need to have a result variable defined, and if that is the case we have to say, okay, this previous values are going to be this, so that for the next one you can use that, and that is going to return you the count of fleets. And let's see how this works. So for this one we have already seen that we can solve this problem 24113, and this actually places them in this order. So this is the array we are creating, and once we create this array it takes a runtime order of n and a space of order of t, and after that we go in the reverse direction in order of t time complexity, and we just check if the previous vehicle arrived before this one. In that case we just increment our count of fleet, which is defined this value called a result, and that should give us the answer. So let's say how it performs. Oops, we made a small mistake here. I equals 0. Oh, I made a mistake here actually. Speed of length. This is float, and this is one value target managed position I, and float speed of I. So did I miss anything here? No. Oh, sorry, I actually made a mistake here. So this is the way to convert that speed value to a float, and I made a mistake there. Oh, this is a value. It's in J. Yep, it passed all the test cases, right? I can submit that. So yes, we had an index J here. Yep, it bit almost everything. So excellent. Thank you for watching.